Laplace transform in system modeling. Introduction. The Laplace transform is a widely used integral transform in mathematics with many applications in science and engineering. The Laplace transform can be interpreted as a transformation from time domain where inputs and outputs are functions of time to the frequency domain where inputs and outputs are functions of complex angular frequency. Laplace transform method have a key role to play in a modern approach to the analysis and design of engineering system. The concept of Laplace transform are applied in the area of science and technology such as electric circuit analysis, communication engineering, control engineering, and nuclear physics, etc. Definition and important properties of Laplace transformation. The definition and some useful properties of Laplace transform which we have to use further for solving problems related to Laplace transform in different engineering fields are listed as follows. Definition. Let f of t be a function of t where t is greater than 0. Then the integral limit 0 to infinity e to the power of minus st into f of t into dt is called Laplace transform of f of t. We denote it as L of f of t or f of s, i.e. L of f of t equals to 0 to infinity e to the power of minus st into f of t into dt equals to f of t s. First one, property of Laplace transform. Linearity property. If f of t and g of t are any two functions of t and alpha comma beta are any two constant, then L of alpha of f of t plus beta of g of t equals to alpha of L of f of t plus beta of L of g of t. Shifting property. If L of f of t equals to f of s, then L of e of a into f of t equals to f of s minus a. Multiplication by t to the power of n property. L of f of t equals to f of s, then L of t to the power of n into f of t equals to minus 1 whole power n into d to the power of n by ds to the power of n into f of s. Laplace transform of derivative. If L of f of t equals to f of s, then L of f to the power of n into t equals to s of n into s to the power of n into f of s minus s to the power of n by 1 into f of 0 minus s to the power of n minus 1 into f dash of 0 minus so on f to the power of n minus 1 into 0. Laplace transform of Bessel's function. L of I of 0 of t equals to 1 by under root s square plus 1 where j naught of t equals to limit k to infinity equals to 0, k equals to 0 to infinity minus 1 to the power of k into 1 by 4 into t square whole power k by k square is called Bessel's function. Inverse Laplace transform. L of f of t equals f of s, then L inverse of f of s equals to f of t is called inverse Laplace transform of f of f. Inverse Laplace transform by convolution theorem. If L inverse of phi 1 of s equals to f1 of t, then L inverse of phi 2 of s equals to f2 of t, then L inverse of phi of 1 into s into phi of 2 equals to limit 0 to t f1 of u into f2 of t minus u into du. Applications of Laplace transform in science and engineering fields. This section describes the application of Laplace transform in area of science and engineering. The Laplace transform is widely used in following science and engineering fields: analysis of electronic circuits. Laplace transform is widely used by electronics engineering to solve quick differential equations occurred in analysis of electric circuits. System modeling. Laplace transformation is used to simplify calculations in system modeling where large number of differential equations are used. Digital signal processing. One cannot imagine solving digital signal problems without employing Laplace transform for nuclear physics. In order to get the true form of radioactive decay, a Laplace transform is used. It may easy to conduct analytic part of nuclear physics possible. 5. Process control. Laplace transform is used for process control. It helps to analyze the variables which, when altered, produce desired manipulations in the result. Some of the examples in the science and engineering fields in which Laplace transform are used to solve the differential equations occurred in the fields. The following examples highlights the importance of Laplace transform in differential engineering fields. 2.1 Laplace transforms to solve differential equations. Ordinary differential equation can be easily solved by Laplace transform method. Without finding the general solution and the arbitrary constant, the method can be illustrated by following example. Differential equation is x into d square y by dx square plus dy by dx plus xy equals to 0. Given y of o equals to 2 comma y dash of y equals to 0. Taking Laplace transform on both sides, we get L of x double y plus L of y dash plus L of xy equals to 0. Then putting boundary condition y of equals to 0 and y dash of 0 equals to 0, we get s square plus 1 into dy by ds plus sy equals to 0. Separating the variables, we get dy by dy plus s into ds by s plus s square plus 1 equals to 0. Integrating both sides, we get log of y bar plus 1 by 2 into log of s square plus 1 equals to log of c. Log of y bar equals to log of c minus log of s square plus 1. Y equals to c by root s square plus 1. Taking inverse Laplace transform, we get y equals to L to the power of minus 1 to c by root s square plus 1. Y equals to c into j naught of x. At x is equals to 0, y of 0 equals to c j of 0. Putting y of 0 equals to 2 and j 0 of 0 equals to 1. We get c equals to 2. Required value of y is y equals to 2 into j naught into x. Laplace transform in simple electric circuit. Consider an electric circuit consists of resistance R, inductance L and the concentric capacity C and the electromotive power of voltage E in a series. A switch is also connected in the circuit. Then by Kirchhoff's law, we get L of di by dt plus R of I plus Q by C equals to E. Example, an inductance of 3 Henry, resistance of ohms and the capacity of 0.02 Faraday are connected in series with the EMF of 300 volts at t equals to 0. The charge on the capacity and the current in the circuit is 0. Find the charge and current at time where t is greater than 0. Solution. Let Q and I be instantaneous charge and current respectively at time t. Then Kirchhoff's law. Applying Laplace transformation on both sides, we get L of d square q by dt n plus 8L of dq by dt plus 25L of q equals to L into 150, where s square of L of q minus sq of 0 minus q dash of 0 plus 8 into SL of q minus q of 0 plus 25 into L of q equals to 150 into L, where L of q we get as 150 by s into s square plus 8s plus 25. Taking inverse Laplace transform on both sides, q equals to n inverse of 150 by s into s square plus 8s plus 25. By method of partial fraction, q equals to n inverse of 6 by s minus 6s plus 4 8 by s square plus 8s plus 25. q equals to 6 into L inverse of 1 by s minus L inverse of 6 into s plus 4 by s plus 4 whole square plus 9 minus L inverse of 24 by s plus 4 whole square plus 9. Using shifting property, q equals to 6 minus 6 into e to the power of minus 40 into cos 3t minus 8e to the power of minus 40 into sin 3t, and I equals to dq by dt, where 50 into e to the power of minus 40 into sin 3t. This is required expression for charge and current at any time where t is greater than 0. Laplace transform in control engineering. Mechanical engineering. In mechanical engineering, Laplace transform is widely used to solve differential equation occurring in mathematical model of mechanical system. To find transfer function of the partial system, following example describes how to use Laplace transform to find transfer functions. The tank shown in the figure is initially empty, t equals to 0. A constant rate of flow q1 is added to for t is greater than 0. The rate at which flows leaves the tank is q0 equals to c as the cross section area of the tank is a. Determine the differential equation of the head h. Identify the time constant and find the transfer function of system. Conclusion. Through this paper, we present the application of Laplace transform in different engineering fields like electronics, mechanical, physics, etc. Besides this, Laplace transform is a very effective tool to simplify very complex problems in the area of stability and control. It goes without saying that Laplace transform is put to tremendous use in engineering field. Thank you.